looking at the sun at 193 angstroms. Small coronal hole turning in, larger coronal hole turning out. Sunspot 2733 grows even larger and emits another B-class flare. And let's see if we can see the flare happen in 94 angstroms. Is it right at the end, I think? Let's zoom in and watch its activity. There was a flare. Yep, that was it. And now our favorite view of all, the ever-popular 171 angstroms. Sunspot 2733, a cycle 24 sunspot. And let's look at the real-time solar wind, as the Earth has just recently crossed the heliospheric current sheet, which we will show you momentarily in the Gong 2. See the phi angles down at 211, which is a continuing coronal hole magnetic connection. Solar wind speed is still around 600 kilometers per second, and solar wind density looks like it's just fluctuated, but is around, I'll say 5 protons per cubic centimeter. Without further ado, let's look at the Gong 2. As you will see, the final frame showing the Earth right in the void. Check it out. There's the last frame. Where's the Earth's orange line gone? There is none. And this likely means that we're already on this side. Keep in mind this data is over 2 hours old, and we'll be looking for that to update soon. And let's look at spaceweathernews.com. See that X-ray flare almost in the C-class range. Check it out. So a high-level B-class flare happened. There's your magnetometer spikes. This got very steep as expected. And at midnight local time here, once again like yesterday for these satellites, we're seeing some signal crossing there at the bottom of the range. So the KP index was all the way up to 5 there, minor geomagnetic storm, and now it's dropped all the way back down to 2. Here's your Cygnets forecast through the 30th. Electron flux dipping as it typically does with such a high solar wind speed. Charging hazards are minor, and the F2 layer is looking pretty normal today. There's your auroral forecasts, slightly elevated with a 600 kilometer per second solar wind. Let's just take a quick look at the total electron count, total electron content rather. Should be a pretty narrow band. Let's see what it does to the South Atlantic anomaly there. Nothing too extravagant, and there's your total electron content forecast. Next, let's look at your Geospace ground perturbations here, as we saw a massive uptick in these yesterday. Documented in yesterday's video. If you haven't checked it out, please feel free. And we see these global magnetic pulses all over the planet. And they're at a higher intensity than they were yesterday. Let that play through one more time. We've got pulses coming out of the Pacific Ocean. Large portions of South Pole magnetism leaking into the southern Indian Ocean there toward Australia. And lines of magnetic field that are more tightly concentrated than they were yesterday. Here's the view from the poles. Like we said, noticing some major ground magnetic perturbations. Let that play through one more time. Here are some magnetosphere movies, starting out with velocity. Some bands of varying velocity coming in the solar wind. Here's your magnetosphere density. So it's an interesting demonstration of the differences here between velocity and density. I mean, sure, F might equal ma, but what you're seeing here is you're seeing low density waves come in. Right at the end here, we'll see one. That's a low density solar wind wave coming in. And you see a couple low density waves come in here near the middle as well. And here's your solar wind pressure, your magnetosphere pressure rather. I should note that we don't really see the angle of attack change yet. These models are very up to date. We're expecting angle of attack to go from down here to up here at any time. And that might have been it happening there at the end. Keep watching it all day if you want to know exactly when it happens. We'll leave links. Next, we've got a cosmic ray downtick. We watch a number of monitors daily, and not surprising, with higher levels of solar activity, we're seeing a downtick here, a little relaxation at Athens. Here's Mexico City, small downtick there also. Here's Moscow neutron monitor, downtick there, still an uptrend over the last 2 weeks. Here's Oulu, Finland, following suit with a small downtick in the cosmic ray flux. DOMC Antarctica, not really on board with that, as it hasn't been recently. And DOMB is indeed agreeing with the rest of the monitors. Small downtick in cosmic rays over the past couple days. Next, we haven't looked at the LASCO C2 for a while, so let's just have a look at that. Small coronal mass ejection there you'll see on the eastern limb, which would be your left. There's a small coronal mass ejection coming out. Does not appear to be Earth-facing. Moving on. At globalincidentmap.com, their live earthquake map, we see a small uptick in earthquakes going back 10 hours here. Got a 4.6 in Japan. Bunch of quakes in Alaska and California, all on the small scale. Papua New Guinea, a 4.9 at 206 kilometers. They should stay on alert for a 5. 4.0 in Larsen Bay, Alaska. 4.9 in Tonga. Followed by a 4.9 in Tonga. At a different depth. It's 2 quakes, folks. Peru got a 5.6. Japan got a 4.9. Afghanistan a 4.1. 4.6 in Japan. Series of quakes in Alaska and California. Chile a 4.0 at depth. Japan a 4.3 at depth. And 1 quake reported repeatedly, 1.3 magnitude in Winchester, California. Volcanoes today. We got Shivaluch going back into explosive activity with a 14,000 foot ash plume. Mount Manam, 18,000 foot ash plume. Fuego, occasional emissions. New on the list, San Cristobal in Nicaragua. Continuous light volcanic ash emissions, producing a cloud up to 8,000 feet. Reventador, volcanic ash detected in satellite. And Sabakaya, unsure if it's still erupting or not. Next, I would draw your attention to a website, electroverse.net. Going to look at 2 articles on there. One, reinforcing what we said yesterday. Sir David Attenborough, a knight of the dumb table. Apparently, Electroverse agrees with us. As temperatures plummet across swaths of the U.S. and Canada, the grand solar minimum is tightening its grip. Look at the GFS runs, a big freeze due to jet stream descent. Yeah, the jet stream's just coming all the way down to Florida, people. Dear idiot, stop telling us that we're on a flight to Florida while trying to drop us off in Alaska. Sir David Attenborough. So, yeah. Another article here about how he's absolutely wrong. Sea ice continues to trend thicker in the Arctic. Total snow mass in the northern hemisphere is well above the 30-year average. Global average temperatures continue to fall. And CO2 has nothing to do with heating the planet. That's right, it's not a greenhouse gas in the context of making the Earth's atmosphere warmer. Or water, for that matter. Here's your global temperature averages. Right here is where the global temperatures were when Al Gore won a Nobel Prize. Here's where they are now. So, you see that? That's global warming for you, folks. And let's look at another article talking about Dr. Robert Higgs. Goodbye, anthropogenic global warming. Man-made global warming believers will by 21 have to admit they were wrong and that CO2 is blameless and that Svensmark's sun/cosmic ray/cloud/temperature link tying temperature to cosmic rays and cloud nucleation and increasing the Earth's albedo are correct. So anyway, we'll leave links to that article as well. Actually, we'll just leave links to electroverse.net. So you can go check it out on a daily basis. By the way, we don't want to reduce CO2. Carbon sequestration activities are some of the dumbest things ever conceived by mankind, especially when the total solar irradiance is dropping. We would prefer to be able to grow plants when the sun's output is weaker. And let's go backwards through some weather data here. TropicalTidbits.com, looking at the 250 millibar upper level winds to follow the jet stream, as it is all over the place. Let's speed that up. Part of this is what just happened, and part of this is the forecast. There's the current situation. If I can get it, there we go. Current situation here. There's a persistent low in the South Pacific. And I think there's a persistent low in the Indian Ocean too. Let's let that play through. Anyway, one of the ways you figure out where the next earthquake is going to strike is you wait for a deep earthquake, and then you look for an anomalous low pressure system. I'm still saying something around the New Zealand area is going to get a 7+ quake. Although the risk should be dropping off, we will be watching the phi angle to see when the earthquake risk goes down. Next, let's look at the GOES water vapor full disk, just for fun. Give you an idea what's going on in the water vapor layer. Not a lot of dry air over the South Atlantic. And a lot of wet air over South America. Check it out. Major convergence going on down there. Next, let's look at the shortwave satellite animation of the full disk. Here's what's going on in the cloud layer. We use a shortwave animation to see the clouds when it's too dark to see them with the visible satellite. There's that. And here's the NASA GOES water vapor map of the US. This map showing you things that are not apparently visible to the human eye, as we on our channel encourage you to see things that are not there. Not because they don't exist, but because you've got the right instruments to view them. Speaking of the right instruments, the Solar Dynamics Observatory is one hell of an instrument. Here's your magnetic lines in 304 angstroms, by the way. I would have you note all the jumbled up lines here, diffuse lines by this coronal hole, and powerful lines emanating from the sunspot and this plage. So, thanks for watching, everybody. We got some serious plasma filament activity going on in the northeast limb. Check it out. That filament was about 3 Earths in diameter there. We'll be doing it all again tomorrow. Please don't forget to like and subscribe if you enjoy the content. Share on your social media. Help us reach 900 and indeed 1,000 subscribers. If you got any ideas for a 900 subscriber special, please leave it in the comments. Thanks, friends, foes, subscribers, haters, and regular viewers. Remember, when you're staring at plasma filaments, don't drink. And if you drink, stare at the plasma filaments anyway. And don't drive.